Right, we are live. Hello again. Been a while since we've done one of these. So what we'll do is continue on with our Nowhere Metaverse room project. So this is where we got last time. This is how far we got. So we've created all the images, laid out our brushwork or volumes. Hang on a second. Let's pause that. What's that? So yes, this is where we got to last time. So that's a couple of weeks, months ago. And what we were working on was this lava pit. So we had to create a lava texture. So we created a basic using texture paint. We painted our texture. And in the meantime, made a few updates to that image. And we've added another grass texture. So let's just load in that one. Open recent number 18. Don't save. So we've modified the, let's go into, there we go. Modified the painted texture for our lava. So again, this was all painted in Blender. And then we've also added a second grass, well, a second and a third actually. Two more grass cards, and those have been placed in and around the scene to just add a bit more variation. We've got some long ones and some of the shorter ones. And these just sit directly on top of the blocks. So that's what we've got so far. And now we're going to just play around with our lava. And this should, well, in Nowhere Metaverse, it won't emit light, but we can set the material up to be full bright. So let's just duplicate and copy that, move that into place. So ordinarily for lava, if this were so basically we've got an issue in the sense that obviously we're dealing with Nowhere Metaverse, which has its own way of rendering surfaces and materials. What it doesn't do, because it's not designed to, it doesn't render volumes. So obviously if you fall into the lava in Minecraft, it's not just a surface texture. It's the same with water. So it's not just a surface texture that you then break past the surface and you're able to see what's, you know, all this ground surfaces. You can't see any of this because inside the lava we have the lava fog, so it's treated as a volume. Obviously in Nowhere we can't do that because we can't render volumes. Hang on a second. Hold on, need to do some moderation. Don't deal with spam in the comments. Yeah, so in Minecraft, it's an actual volume. So when you break past the surface skin or the surface layer, you're actually interacting with essentially fog that gives the impression that you are inside the lava. Nowhere doesn't have that. So where we've been dropping blocks into place to describe the world, and then we've optimized those blocks by removing all the hidden surfaces. Let's just split that. That's the Y key. Just move that out of the way. So we've got rid of all the hidden surfaces in order to optimize our level. For the sake of, let's just undo. For the sake of the lava pit, essentially, excuse me, essentially all we need is the surface skin. So rather than dealing with to mute there for a second. Rather than dealing with lots and lots of blocks, what we can do, now that we have our lava pit shape, all we really need to do is move a block into position relative to the surface, and we'll have to decrease its height slightly, because although the blocks below the surface are one by one unit, the surface is actually slightly shorter than 1 by 1. So what we can do is just lower that, remove these unused surfaces, just delete them. So mesh, delete, or X faces. And then all we need to do is just copy paste or duplicate this surface. So Shift D. And we have this set up so that we are snapping to the grid. So all we're doing is duplicating that surface across our hole. Let's select more of them. And we are snapped to the grid, so it's automatically following the grid. Select those two. Those, and then we want a little effect here, so we want the lava to follow this and drip off the end there, because I'm going to do another island of stone and lava. So duplicate, and again we need to duplicate that, drop it down half, or let's just drop it down by half. So that should be half the height of the full block. No, it's not. Once more. So holding Shift down to manipulate the selection in locked increments, because if we press the Control key down, which is what we would normally do, that disables snapping. So it moves the selection freely. We want to avoid doing that. So when snapping is enabled, we use the Shift key to move in increments. Whoops. But make sure that you click the axis you want to move the object or the selection in first to initiate, and then hold the Shift key down, because if you hold Shift first and then do that, it'll manipulate the object in a different way. So we've got that. Let's duplicate that in that position. Rotate. Snap to increments. So that's 90. Move that there. Down 1. So we now need to duplicate this. Well, it depends how we want to do this actually, because let's go with duplicate, duplicate, duplicate. Duplicate. Right, and then edge select. Grab that. Shift. That's the end of the lava. We need to fill that. So we'll have to create a face there. So let's go to vertex, select those two, extrude, escape just to reset, then hold shift, there we go. That just gives us the edge that we can then fill. Obviously we have to redo the UV maps here, so I select UV map, zoom in to our selection, where's our lava? So that's the top face. That's that. And press the U key, unwrap. That's not going to do it. So actually, let's pin that. Select all. P. UV unwrap. So we don't want it angled like that. So in the UV editor, we want to just select the UVs or the UV vertices, and it's going to distort our texture alignment. So this is where it gets a little tricky, because I need to double check how this is done in Minecraft. Because ideally you don't want that to distort, but obviously it doesn't do that. That's the correct mapping relative to the shape. I wonder if I could leave it like that actually. That should be okay. Right, so we need duplicate, reset, rotate. Oops, wrong one. Rotate. Hold control. See, because it doesn't do that in Minecraft, does it? don't get half block sections. So from here, what it would actually do, I need to double check this later. Just let's delete that. Delete face. What it does, let's double check this later. Is that, but that looks a little weird. So yeah, I have to double check that later. We can join those together. So select our edges, press the F key. Edges, that's 2. Extrude. And same with that one, extrude. Drop that down into the corner. UV map, unwrap. So which way around is that? Select. That's the bottom. So rotate that. That's top right corner. So let's get that to. Have I got pixel snap on? It should be, and it's not. Corner. Oops. Right, so those are 2 different corners. So how is this? Okay, that's right. Because it's tiling. Right, so that's that. So same again with this one. Extrude. Or maybe let's extrude these first. Extrude. Faces. Unwrap. This is where temporarily drawing something on our texture helps with our alignments. So that's upside down. That's the right way up. Right, so that continues, so that should follow on, same with that one. Right, let's get these into the corner and then make them larger. But we want those down here. And these two stay put. So that's a little tip. So that is the wrong way around, that one. So you don't need to do this necessarily. And in Minecraft, lava is one of those textures that is, generally speaking, it has an alignment, but so all these faces all point in the same direction. But in Minecraft, there are certain situations where the lava texture is rotated. So in some circumstances, you will see the repetitious pattern across a large area of lava. And in some spots, you'll see that the lava texture has been rotated. And it's done literally just to break up that tiling artifact, that repetition that you can see across a large surface. Grass is the other one that does that. So any large areas of grass, they do the same thing. It's why grass in particular, you can't see the repetitious pattern because the texture is randomly rotated, which makes it difficult to see that pattern. So there are a couple of materials in Minecraft that do that don't necessarily always follow the tiling. So let's extrude that vertex so that we can create, and it goes, create a face here and a face here. Yeah, so I need to double check how this is actually done in Minecraft, because face, it would seem a little, so select those and unwrap. So there's that face, there's that. So we want to carry on that alignment again. Whoops. Vertex. But we need to carry on the tiling. So this is actually going to be, whoops. Right, so it's joined, it's auto joined that one. So let's hide that or deselect it and flip this. UV mirror, y-axis. That's the wrong way. Undo, undo. No, that was right. And then No, that's the top of the... That's the top. So it's the long edge, isn't it? It's that edge. So it's too easy to get confused with this stuff. So let's just pin those. Pin. Just like that. Unwrap. Right, there we go. Yeah, I have to check how this is done in Minecraft, because obviously, so long as we have the UV aligned to the image, the pixels are aligned correctly relative to the UV. Or aligned to the face. But that looks kind of... Ordinarily that would look kind of weird. Let's do the same thing here. So select those, pin, select. Oh, we haven't done one on this side, so let's just do that. Edge, F, faces. Oh, we did pin that. Undo, unwrap. Yeah, so that's technically that's correct, but we'll, like I say, I'll check this later. Pin that, unwrap. I need to double check these as well. So what would normally happen here? I don't think because we've got a block under there, so let's just hide this for now. Because the way that it works in Minecraft is whenever there's a step, the lava just half steps down. So it would then just half step and end at this point. So we need, for that lava section to work, so that end block would be here. Then we would have a half height block, oops, here. Then it would end, but we're on the snow, so we have to change that out. Still looks a little odd, but change those out. I want dirt, assign, back our lava, extrude, face, make sure that is pinned. Right, so this has inadvertently got some pins on it, so we want to remove those. So select all our UVs and unpin, which is Alt P. That'll clear all of that. Select R, Control. Yeah, see, because what's happening, so again, yeah, I need to double check all of this in Minecraft, because what's happening is that when we've got this set of surfaces set up correctly relative to the texture so that it's mapped correctly, the problem starts to occur at joints. So we've got this side panel that should be tiling correctly relative to the transition across those two surfaces, but it doesn't, because obviously we're dealing with completely different surfaces and surface volumes essentially. So we can mitigate it to a certain degree, but then we introduce problems where we have texture distortion. So the question is, does the game maintain the texture it's not orientation, but the texture fidelity relative to its mapping across surfaces, or does it allow texture distortion in order to get a transition? So we have, well, it's incorrect now, but you either have correct transitions across surfaces like this, or you have correct transitions across surfaces like this. But the problem there is that if you want this one, you have to distort this one in order to accommodate this transition. Whereas with this one, vertex select, in order to get the transition correct this way, we create a problem here. So maybe it's all fudged. So the edge is blurred or something in Minecraft. So we need another half block transition here. So we're going to do a loop cut, because we only need half the block. So edge, edge, face, edge, edge, face. So pin that, pin, select these two, map those correct relative to, and again you see the same sort of problem here. So we have correct transition this way, but not this way, because obviously this edge is not aligned to this orientation. So I'll have to check how all of that's done in Minecraft, what it does. Oh, and there's this edge here. So let's go with extruding this sideways. And grabbing that vertex and moving that up. So we'll grab that face. Well, that's the problem, Hemabond. Because when you do that, you introduce those mapping issues that we were just talking about. So, yeah, ordinarily you would expect them to be just vertical. So let's just rotate that round. You'd expect them to be like that, right? But you can see, I don't know how clear that is, but you can see that we've got misaligned pixel alignments. So what does Minecraft do at the edges? Because that would be, this is the correct mapping for our blocks, so that we get the transition of the pixels over the edge. So it's all just straight UV mapped. So you're going to get tiling what's the word? Continuity issues at the edge of blocks. Right, I thought so. It's been a while since I played Minecraft, so I wasn't quite sure. So all of these surfaces are going to be basically mapped essentially one, well, that's actually half a block, but like so. Seems kind of weird, but I guess within the Minecraft environment, the sort of the accuracy isn't really that much of a an issue. So that's half a block. How big's that? Yeah, plus it's scrolling, yeah. Right, so we'll do this then. It's just a quick fix. Yeah, thanks for that, Homie Bond. I wasn't quite sure. Wasn't sure about all of that because I haven't played Minecraft in a while. So which edge is that then? Alright, so we have to rotate that way around, so it's all pointing in the same. There we go. Set. Oh, we've got a, yeah, so we haven't joined all the surfaces yet, so let's just do that whilst we're here. So select all, mesh, clean up, merge by distance, 103. So that should have solved that. Has, yeah, the way that Minecraft does what it does can be a little confusing sometimes when you're trying to replicate that look. Yeah, so that would be, that's the bottom of the block. So now we have an alignment issue on this block, but it seems very much so that that doesn't really, so let's go down there. Let's leave that. So there is one thing that we can do. So this has taken a bit longer than I expected to do. So what we might do is continue this in another stream. But before, let's get rid of that. Before exiting the stream, Let's go into rendered view. Turn down the main sunlight. Because shading, emission strength, what we can do, and this is just for Blender, this wouldn't work in Nowhere. We can set our texture to emit or appear to emit. So this is basically turning our texture into a full bright image. So it gives the appearance of emitting light, so it'll be brighter, air quotes, than the surrounding environment. But in Eevee, this doesn't do anything. Let's just save this before we do this, just in case it conks out on us. 19. So if we switch to Eevee, not Eevee, Cycles, we can see how it affects the scene. It actually illuminates the scene because of the emission. But in Cycles, in Eevee, we can't do that. So the way that we can, again, just for the sake of using Blender, just doing this in Blender, because I don't think Nowhere has this capability, what we can do is add a light probe, and depending on which version of Blender you're using, so this is 3.6, so never change versions in the middle of a project, and add an irradiance volume. Where's that dropped in? There it is. And what we can do with this is basically block out the area. We can use scale, expand that, expand that. And what it'll do is it'll capture indirect lighting and apply it to the scene. So it essentially bakes a light map temporarily that will do the same sort of thing. So we have to go into render properties. Now, which one was it? Indirect lighting. Whoops. Indirect lighting, and then just click on the bake indirect lighting button. And it bakes it. Obviously it's gone a bit wonky because of the way that we've got this set up, but we can see how it's baked. So what it's basically done is essentially baked a set of localized light maps that it's applying to surfaces based on the emission properties or the indirect lighting properties of our material. So now that it's baked that, we can move around Eevee. Yeah, Eevee. We can move around Eevee without the performance issues. So we can keep that light probe in place just for the sake of seeing how that lava texture would be illuminating the scene. And it doesn't require us moving over to cycles and getting this performance problems. Let's just save this file, save as. And then, yes, we'll continue the lava. So what we'll do in the next stream, hopefully that's not in another 6 months, we'll create a little lava pool. So we'll do a, under here, we'll create another platform with this lava dripping down, creating a lava pool as another island. Oh, and of course that light probes are only visible in render display, don't display in material preview. So in order to get this effect in Nowhere Metaverse, you would have to bake light maps. So you'd have to bake the entire scene with light maps in order to get this effect. Let's just texture paint, reload image. So if we watch the lava texture, it'll just revert it back to what it was. So we don't have the T's all over the place. Yeah, I guess the straight mapping, it makes sense. Yeah. Otherwise you end up with all sorts of weird awkwardness. That looks kind of cool, actually. So yeah, the next stream we'll create a platform under here that's got a lava pool, a bigger lava pool. And then once we've done that, we'll get the scene prepped for Nowhere Metaverse and see about exporting it for that. Right, we'll call it quits there. And thanks for the technical assistance, Hemmerbond. Can Blender use a single world UV that is applied to an, similar to how Quake editors do UV mapping? Good question. No, I don't. I mean, you might be able to do something like that if you were to use geometry nodes, because I know what you're talking about. And as far as I'm aware, Blender doesn't do that by default. The closest analogy to that, I guess, would be just, you know, one-to-one mapping, which is kind of what, you know, Minecraft is doing. But that particular type of UV distribution is unique to BSP. Yeah. I don't know about cube mapping, but I get what you're trying to get at. It's the idea of that you would cut into something, cut into a mesh, and it would automatically distribute the UV relative to literally what we've just been doing with Minecraft. So it's always going to have UVs in a fixed orientation regardless as to which way the face is pointing or cut or aligned. So default wise, where are we? I mean, essentially, I suppose that would be a cube projection, maybe. is probably the closest, but then you're projecting from four sides of a cube rather than a specific orientation. Because the only direct corollary is project from view, but obviously that then distorts UVs relative to the orientation that you are looking at. So if we are looking at this from that perspective, all these surfaces that we can see would be UV mapped correctly, and any new shapes you added, those would also be UV mapped correctly. But all the surfaces that are not on that orientation are distorted. Yeah, possibly. If your cube is the size of your voxels, air quotes, it'll tile. Yeah, that's kind of what this is set up as. So we've got our raw blocks. These have been mapped as is. So they're all one-to-one surfaces. So each surface is mapped to our UV one-to-one. So if we just click on that, going to there. So they're all one-to-one mapped. So yeah, anytime you add something from these blocks, you're going to get exactly the same mapping. So the issue comes, or the issue arises when we do, you know, half blocks or half steps or slopes, which is where, as you mentioned, Minecraft doesn't necessarily care about that. It maps everything in a particular fixed orientation because it doesn't need to care about what happens at the edges, because those are fudged or blurred, or, you know, the what would ordinarily be an error, a UV mapping error, is fudged and, yeah, scroll downwards. It's fudged and obfuscated by the fact that the texture is animated. So it's this edge, or these edges, would be hidden or disguised by the fact that this is, you know, the texture is wobbling and animating. But the base block, where's it gone? The base block just replicates, you know, without issue. And it would be the same for if you are doing any volume-based editing, so Quake, IdTech, something that's going to be open in Unreal, not Unreal, in GTK Radiant or Radiant. It's, yeah, I mean, even if you do something like that, so if you made a level in Blender and you imported that into Radiant, any aberrant UV mapping that you are able to do in Blender, so like our edges here that we were just talking about, those would be realigned relative to the Radiant BSP expectations of how UVs behave. So these would be reset. So this one, for example, would be, whoops, that's still joined to that. So this one would be reset and mapped square on, like so. Because BSP doesn't have odd orientations like this, like a proper... Let's just fix that whilst we're here. It doesn't have proper UV editing capabilities. So it's a little... Why's that gone wonky? kind of difficult keeping tracks of which way the faces are supposed to be pointing. Yeah, so it's that way. But yeah, if you wanted to do something like that, in terms of have a fixed orientation UV mapping to your objects as you make them in the same way that it does that for BSP editing, you'd likely have to do it with geometry nodes. I don't think Blender's default UV capabilities can do that, except, you know, the default options and trying to work around those. But even then, that's not quite the same thing, because BSP, as you know, is all mapped one-to-one surface-wise. Right, so let's get back to this, turn it into render view so we have a pretty picture to look at. Yep, thumbs up too. Right, we'll call it quits there, and excuse me, and we shall finish this off, hopefully, in the next stream. So again, we'll just create a cabinet underneath with some lava in it and get it sorted out for Metaverse. Nowhere Metaverse. Right, thanks for watching, lurkers. Thanks for the assistance, Homeobond, and Homeobond. And we shall see you on the next stream. So, bye for now.